So welcome back. This is the part 1 continuing second video. So we are starting microarchitecture. Here we will introduce the detail in the microarchitecture component. So as you know, we have the memory element and the combinational part. So in the memory element, in this class we will discuss about the program counter in detail, what is instruction memory, register file, data memory. And on the other hand, the combinational part, we will study the arithmetic logic unit, sign extended unit, and the multiplexer. These are the combinational part, and these are the memories. Well, let's move for the detail. So as you know, in this class, keep in mind that we will talk about the load word instruction. Particularly, the instruction is load word $T2, 32, and then the base base address is 0, offset 32. That means 0 plus 32 is 32. And once again, if you convert this instruction to a 32-bit MIPS binary, we'll get this 32-bit instruction where this part is the immediate, the 32, and this is the other part. And these are some components, we say. So this is the program counter having the input, output, and the clock. The instruction register having input, output. These are the register file. This is the enables, clock input, and different inputs and different ports. Similarly, this is the memory. And we will go through all this, and this the green color are the combinational part. This selector, arithmetic logic unit having the controller output and source input. This is the sign extension circuit having the input and output bit. So let's have a look if all the things together are connected. Okay, so here is I put it a different color, but they are serving the same purposes. So these are the program counter, and this is a combinational part that add 4 plus 4 circuit, because you know every time you need to add this program counter increment by 4. So this part, green part, is combinational part. Here is a register file. So you need to read and write operation to the register through this. This is the for the write enable, and here is the clock. So once you have the write enable 1, you will work the clock raise operation here. We will study in detail. So this block and seems to go this combinational part, arithmetic logic unit having the control. So this arithmetic logic unit having several operations, not only just the addition, but here in particular 0, 1, 0 is for the addition. Later on we have data memory for the read and write from the memory, and this is gonna here again for the write operation, and this is sign extension that it takes a 16-bit input and send the 32-bit after extended to sign. So we will study all these 1, 2, 3, 4, 5, 6, 7 components individually. Well, so let's start with the instruction memory. As you know, these are parents a bit for the memory. So you have memory address and the instruction here. So the instruction memory as a single read port here is 32-bit, right? So it takes a 32-bit instruction address input in A and reads the 32-bit data here, RD. So for example, here is the example. If A, the address is here 104.004.00004, okay. So the RD So this is the address and this is the instruction. So the RD will be this 0, 2, 3, 2. I mean this one 0, 2, 3, 2. So this is the instruction. So this is instruction memory, address, instruction. Well, move to the next one, register file. Well, we have extensively studied register in the classes of MIPS assembly. So these are the register bango number, this is the register name, and this is the data. So each register is 32-bit register, can hold the 32-bit data, and these are the sample of data. And this register file having the input, it's 5-bit input, 5-bit input A1, A2, and A3, while we have the enables and clock, while we have the RD, R2, and the WD3. So we know that register, we need to read and write from the register always. Here, the A1 and A2 are used to with the register number, and the data is here 32-bit number. For example, if A1 is 5, in binary is 102, that means the register number 5 here, okay, in the A1, so in the RD1 we will get the value of this. Make sense? Again, so this is the register number is 5, if it's a 5-bit. So if the register number is 5 here, so that means if this is 5, that means A1 here, 5 is A1, the input A1 here, you will get the RD is the value of A1 here. Similarly, it should be 6 here. It should be 6 here, okay. And then A2 is the number of 6, A2. So what we'll have, you will get this value, CAA and RD2. Well, the remaining part is A3, WD3, clock, and then E3. These are for write operation. Let's move it. Here we go. So once you have this WE3 enable with the range code, then you can do have this value. If the WD3 value is this, you write A3. If the A3 is this value 111, so you will write the value this to the A3. That means the A3 value is overridden with this value. So this is work with the raising edge of the clock, while this is enabled. So this is two things, the read and write for this register. Well, the next one is data memory. So it is a bit different than instruction memory, because in instruction memory only have the one input and one output, address and then the data. But here we have also the write operation for the memory. So read from the memory and write to the memory. So when write, need to WE enable with the clogging raises to get the WD. So the data memory has a single read-write port. If the write is enabled, that means WE is 1, it writes the data WD into the address A. The address is given here. In the raising of clock edge, if the write is enabled is 0, it reads the operation from the RD. So these are data memory. The next one is a program counter. Well, program counter is also a 32-bit register, and particularly the program counter contains the address of the instruction to be executed, right? And at the raising edge of the clock, the value is given to the PC is taken and held. Well, and that value is always to the output of the program counter. Now move to the combinational part, okay? So like the program counter, data memory, register file, and the instruction memory, the memory part. Now we move to the second part, the arithmetic logic unit or the combinational circuit. The first one is arithmetic logic unit. So as I said that the ALU is not it's a 3-bit controller here, and we have a different program function, AND operation or operation addition. So addition is 0, 1, 0. In our case, for this load word operation, we need to add this source A and source B. So we will use add, which one is add? This one, right? Yeah. Oh, sorry. Oops. So in simply, we have the 32-bit input A and B and 3-bit controller here. Okay, and the control bits flows in table 5.1 here, and the output is 0 for the 0 and the result for the bitwise operator, and then for the arithmetic operator, right? The result here. The second one is a sign extended. So this is also a combinational part that takes a, let's take a ledger. So in the input, it takes a 16-bit and it converts the 32-bit by adding the extended extension. So be careful about the positive and the negative. Okay. The first thing is the task of this combinational part is converting a 32-bit to a 16-bit to a 32-bit based on the sign. So it added all the 0 if this is positive, the input is positive, and it include all the 1s if the input is negative for the 2's complement format, right? The next one is selector, multiplexer, right? In our figure that I showed you earlier, that doesn't have the multiplexer. Let's move to that slide that I show you, this one. Yeah, here we don't have multiplexer, but later on when we move, we will find many multiplexer. So all of you know that this is based on the selector. We'll have a output from one of the input. Here is a 1-bit control. So you have a 1-bit, but a similar diagram is for the 5-bit and 32 bits, right? It's remain the same. So here you can see that if the control input is 0, that means here is 0. The 0th input is, or the input is, or the output is 1, right? It's a pretty simple operation. So this is all about the introduction of the part. Now we will switch to the part 2 in the next video, while we will discuss about the data part.